Hey guys, welcome back to SUNA Academy. If you are new here, myself Karthikeya, I'll be teaching you concepts of physics that are related to JEE Mains, the advanced NEET, UG and many physics Olympiads that you'll be coming across in a grades 8, 9 and 10. So if you haven't subscribed to our channel, do subscribe to our channel, hit the bell icon right beside. Do like our videos and share our videos to your friends and your fellow aspirants. So the next subtopic you'll be coming across in a series of videos on vectors is triangle law of vectorization. So let us look what does triangle law of vectorization state. Okay. So if you have a vector A bar like this, and if you have vector b bar like this, okay, the resultant vector or the closing vector is like it starts from the tail of A and ends at the head of B, and this C bar is nothing but the addition of two vectors A bar and B bar. Okay, see how the C bar is starting. It is starting from the tail of B and ending at the head of A. Okay, and this is also similar to the polygon law of vector addition. Okay, if you have some sequence of vectors, okay, A bar, B bar, C bar, D bar and E bar, okay, and the closing vector or the resultant vector which starts from the tail of A and ends at the head of E, okay, and this resultant vector R bar is nothing but sum of all the vectors A bar plus B bar plus C bar plus D bar plus E bar. Okay, and let me also remind you some property which this triangle of vector addition follows, and that is commutative property. Okay, law of vector addition follows this property, and this property is nothing but A bar plus B bar is same as B bar plus A. Okay, and it also obeys another property, associative property, and this means A bar plus B bar plus C bar is equal to A bar plus B bar plus C bar. Okay, so law of vector addition follows these two properties. So now let us look into the parallelogram law of vectors. Okay, so what does this actually state? So if you have a parallelogram, okay, something like this, and if this is your A bar, vector A bar, and this is a vector B bar, okay, and the diagonal which is actually starting from here and ending there, right there, is nothing but your resultant vector R bar. Okay, so this will be your resultant vector R bar. So let me prove also diagrammatically. So if this is your B bar, if I'll be considering this vector, okay, this vector, since it is parallel to B bar and it is of same length of B, this can also be your B bar. And from the simple triangle of vector addition, your A bar plus B bar is nothing but your R bar. Okay, and let's say angle between A bar and B bar is theta, and angle between R bar and is alpha. Okay, now how can you actually find the magnitude of resultant vector R bar? Okay, magnitude of resultant vector R bar. Okay, so let me actually complete this parallelogram in this manner, and let me say this is your 90 degrees. Okay, and let me also mark them this as O, M, N, and this to be P. Okay, so from simple Pythagoras theorem you can say that your OP square is nothing but OM plus MN whole square plus PN square, right? Okay, your OP square is nothing but mod R square, right? Your OM square, OM is nothing but mod A, and you are now going to find what is MN whole square, MN and PN, right? Okay, so let us consider this triangle. If this is theta, and then this also will be your theta, right? So if this is your theta, this is your M, and this is your P, and from in the diagram you can say this is a mod B bar, and from simple trigonometry your Mn and Pn, okay, let us relate that to mod B. So your Mn is related to mod B with the trigonometric ratio cos, right? So your cos theta is nothing but Mn by mod B, adjacent side by hypotenuse, and your sin theta is nothing but your Pn, opposite side by hypotenuse. The hypotenuse is mod B. right? So this is your sine theta. So from this you can say that your mn is nothing but mod b times cos theta, and your pn is nothing but mod b times your sine theta. So let us put that in your mod r square. So your mod r square is nothing but mod a square, sorry, mod a plus mn is nothing but mod b cos theta whole square plus mod b sin theta whole square. So this is nothing but mod a square plus mod b square cos square theta plus 2 times mod a mod b cos theta, right? And this way is your mod b square sin square theta, right? So from this you can actually take your mod b square common, right? So when we will taking mod b square common, you will be left out with sin square theta plus cos square theta. Sin square theta plus cos square theta will be turning out to be 1. So this will be mod a square plus mod b square plus 2 times mod a mod b cos theta, right? This is your mod r square, and your mod r is nothing but root over of this mod a square plus mod b square plus 2 mod a mod b cos theta. And what is theta? Theta is angle between a bar and b bar, okay? And now from this you can conclude that if you have two vectors if you have two vectors a bar and b bar, if they subtend some angle theta between them, then the resultant vector r bar is nothing but or magnitude of resultant vector r bar is nothing but root over mod a square plus mod b square plus 2 times mod a mod b cos theta. Hey guys, if you haven't liked our video, do like our video to support and encourage us. Now let us also get into the other case when you'll be asked to find the angle between the resultant vector r bar and the angle between a bar. So that is nothing but alpha. So how can you find the alpha angle alpha? So taking up tan alpha, your tan alpha is nothing but opposite side by adjacent side. Your opposite side for the right angle triangle which has alpha as one of the angle that is going to be this triangle, and that opposite side is Pn, right, by OM plus Mn, right? And your Pn is nothing but mod B sin theta by OM. OM is nothing but mod A plus your Mn is nothing but mod B cos theta. So your value of alpha is simply tan inverse mod B sin theta by mod A plus mod B cos theta. Okay, so this is the value of alpha. Okay, now let us get into the next subtopic, component of vectors. And if you are going to consider your coordinate axis, your x axis and your y axis, and if there is some vector from origin, let's say suppose a bar, and this has got a length of or magnitude mod a, and component of vector mean a component of this vector along x-axis. Okay, so component of this vector along x-axis would be your ax, okay, your ax, okay, and your a bar mod a bar, and this component along y-axis will be a y bar, okay. And let us say this has got magnitude mod a y bar, and this has got mod a x bar, okay. Now let me find out what is mod ax bar and what is mod ay bar. Okay, let us say this is some angle theta, and mod ax bar and mod a bar is actually related with the trigonometric ratio cosine, right? So your cos theta is nothing but adjacent side mod x by mod a, and your sin theta is nothing but mod a y opposite side, okay, by hypotenuse mod a. So your ax mod ax is nothing but mod a cos theta, and your mod ay is nothing but mod A sin theta. Okay, so in other terms, your A bar can also be said that it is the combination of AX I cap plus AY j cap. Okay, mod AX I cap and mod AY j cap, and your AX I cap is nothing but mod A cos theta times I cap. Okay, a vector is actually formed by multiplying the magnitude and the directional unit vector of it. Okay, and even mod A sin theta times j cap. So this is your vector A bar. In my next video, I'll be discussing the applications which are actually related to component of vectors. Till then, stay tuned to our channel. If you haven't subscribed to our channel, do subscribe to our channel and like our videos and share our videos to your friends and your fellow husbands. Don't forget to hit the bell icon right beside it. Thank you.